fast track math. What if I told you there's a simple way to find out how long it takes for your money to triple, or solve equations that look impossible, like 8e to the power 3 minus 2x equals 4? In today's fast track math lesson, we're breaking down exponential and logarithmic equations step by step, so you can finally stop guessing and start solving with confidence. A logarithm is the inverse operation of exponentiation. In simple terms, while exponents ask, what do we get when we raise a base to a power? Logarithms ask, what power do we need to raise a base to get a certain number? So here's the logarithmic function. Y equals log of x base b is the equivalent of b to the power y equals x, where b is the base. B is greater than 0 and not equal to 1. That's the number being raised to a power. X is what we call the argument, that is the result we're working backwards from. And y is the output, that is the exponent that satisfies the equation. So for instance, if I have log of 8 base 2 equals 3, in exponential form the equivalent is 2 cubed is equal to 8. So here are the steps for solving exponential equations. First, you want to isolate the exponential expression. You want to get the exponential term on one side of the equation. Then, you want to take the logarithm of each side. Either apply log or natural logarithm to both sides of the equation. And then you can use log rules to bring the exponent down. Apply the power rule, that is if you have log of a to the power b, that is equal to b times log of a. And then you can simplify and solve for the variable using algebraic techniques to isolate and solve for x. And finally, always check your answer to make sure that the log argument is positive and the solution is valid. So here's our first example. Let's say we want to solve 3 to the power x plus 2 equals 9. In other words, find the value of x that makes this equation true. So in this case, we can rewrite 9 as 3 squared. So we can write both sides with the same base. 3 to the power x plus 2 is equal to 3 squared. And then we can set the exponents equal because the bases are equal. So x plus 2 is equal to 2. And solving for x, if we subtract 2 from both sides, x is equal to 0. So our solution is x is equal to 0. And if we plug in back x equals 0 into our original equation, 3 to the power 0 plus 2 is 3 to the power of 2, which is 9. So we know our final answer is correct. But what if our bases are different? So for instance, if we want to solve 3 to the power x plus 2 equals 8. Now we will need to take the logarithm on both sides. So log of 3 to the power x plus 2 equals to log of 8. Then using the power rule, I can bring the exponent down. X plus 2 times log of 3 is equal to log of 8. So then I can solve for x by dividing by log of 3 on both sides and then subtracting 2 from both sides. So x is equal to log of 8 over log of 3 minus 2. And you can quickly plug that into your calculator and you'll see that x is approximately negative 0.107. So when the bases don't match, we can just use logarithm or natural log on both sides in order to solve for the variable. If you like what you see so far, please like this video and subscribe for more. It really helps our channel. Let's look at the natural logarithm now. So what is e? The natural logarithm has base e, that is approximately 2.718. That is a fundamental mathematical constant. So ln x is the equivalent of log of x base e. So it's a natural logarithmic function. So the relationship between the two is that let's say you have ln a equals b. It means that e to the power b equals a. So once again, the base is e in this case. So let's see this example. What if we want to solve 8 to the power 3 minus 2x equals 4? First, we will take the natural log or ln on both sides. And using the rule to bring the exponent down, this becomes 3 minus 2x times ln 8 equals ln 4. Then we can divide both sides by ln 8. So 3 minus 2x equals ln 4 over ln 8. If we subtract 3 from both sides, we get negative 2x equals ln 4 over ln 8 minus 3. And then finally, solving for x, we can divide both sides by negative 2. So x will be equal to ln 4 over ln 8 minus 3. All this divided by negative 2, which will give us a solution of 7 over 6 or 1.66666. So always check that the argument inside the log is positive, because logs of 0 or negative numbers are undefined and therefore the answer will be invalid. So here you can plug in back x equals 7 over 6 into your equation to make sure that it is indeed equal to 4. Now let's talk about money. What if you invest $2,500 at 4% annual interest, compounded semi-annually, and you want to know how long will it take for your investment to reach a value of $10,000? So here's a formula here. A is the accumulated amount equals P, which is the principal, times 1 plus R over N, where R is your interest rate, N is your compounded period, to the power nt, where t is the time. So in our case, our principal P is 2,500. R is our interest rate. If I read this in decimal form, that will be 0.04. The compounding period is 2, n equals 2 because it is compounded semi-annually. And we're looking for t, how long it will take for A to reach a value of $10,000. So if we set up our equation, 10,000 is equal to 2,500 times 1 plus 0.04 over 2 to the power 2t. And we're looking for t here. We want to see how long it will take. So first, if we divide both sides by 2,500, 10,000 divided by 2,500 is 4. And if we simplify it inside our parentheses here, 0.04 divided by 2 is 0.02. So we have 1.02 to the power 2t. Then we can take the log or the natural log on each side. So ln 4 will be equal to 2t times ln of 1.02. And finally, in order to solve for t, we can divide both sides by 2 times ln of 1.02. And that is approximately 35. You can see in your calculator that that will be approximately 35. In other words, it will take about 35 years for your investment to quadruple. So the value of the investment for it to reach $10,000 if you originally invested $2,500 will quadruple in about 35 years. Now, what if you still invest that $2,500 at 4% annual interest, but this time the interest is compounded continuously? How long will it take to reach $10,000 now? So here's a formula. A is equal to P times E to the power RT. So A is still the accumulated amount after T years. P is the principal. R is the interest rate in decimal, and T is the time. So if we're rewriting our formula, here our accumulated amount is $10,000. Our principal P is 2,500 and our interest rate is 0.04. So 10,000 is equal to 2,500 times e to the power 0.04. If we simplify this, dividing both sides by 2,500, we get 4 is equal to e to the power 0.04t. And if we take the natural log on each side, ln 4 will be equal to 0.04 because ln and e will cancel each other out. And finally, solving for t, you can divide both sides by 0.04, and you'll see that ln 4 divided by 0.04 is approximately equal to 34.66. So therefore, it will take slightly less time for your investment to quadruple if it is invested at 4% interest compounded continuously. So now here's your challenge. I want you to solve for x. For the equation 5 to the power 2x minus 1 equals 20. So you'll want to isolate the exponential and take the log of both sides. And please comment your answer below. So great job working on those examples. Remember that exponential equations are all about isolating, logging, and solving. And if this lesson helped, hit that like button, subscribe to Fast Track Math, and turn on the bell notification so you don't miss our next quick math tip. And don't forget, math success starts when you stay on the fast track.